Hey everyone! Welcome back to Biochemistry Simplified. Thanks for tuning in to part 2. If you enjoyed the first video, you're in the right place. Don't forget to like, subscribe, and hit that bell icon so you don't miss out.
Hello, welcome to Biochemistry Simplified. This is the continuation of the first video on my YouTube channel. My name is Dr. ELIC. Good day everyone from wherever you're watching. Good morning, good afternoon, good evening. As part of the continuation of the part 1 video of Biochemistry Simplified, we'll begin this today with this video looking specifically at the structures of the reactive steps involved in the glycolytic pathway. So we began by looking at the glycolysis overview, and in the first step we've established that there are 10 reactive steps of the glycolytic pathway, which in organization can be divided into 2 parts, known as the preparatory phase, which is the first 5 reactions, and the payoff phase, which is the second 5 reactions. We established in the first lecture that in the preparatory phase, the 2 molecules of adenosine triphosphate, ATP, was used up, and in the second phase, which is the payoff phase, 4 molecules were produced, giving a net molecules of 2 ATP production. Today we want to look at the individual reactive steps, and we'll begin by looking at the glucose molecule right here. This is the glucose molecule in the preparatory phase, and it's the substrate that starts the 10 reactive steps of the glycolytic pathway. So we look at the first step, which is actually the phosphorylation of the glucose to glucose 6-phosphate. So the glucose 6-phosphate, the glucose here at the carbon 6 is phosphorylated in this first reaction to glucose 6-phosphate. So it's important to know that the phosphate group attached here as a result of the phosphorylation of glucose to glucose 6-phosphate is actually the phosphoryl group that is attached. So at this point here, you have the phosphoryl group attached and not the phosphate group. So this phosphate group here is actually the PO3 2-. So what you have here is PO3 2-, PO3 2-, which is actually different from the so it's PO3 2-, which is actually different from the PO4, which is the phosphate. Now in step 2, we simply have an isomerism reaction there, where the glucose 6-phosphate is converted to fructose 6-phosphate, and same molecule but now an isomer, so glucose to fructose. So in step 3, we have the step 3 here. Now we have the fructose 6-phosphate being phosphorylated again. So another phosphorylation reaction takes place in step 3, and fructose 6-phosphate is phosphorylated at carbon 1, giving you the fructose 1,6 biphosphate, the fructose 1,6 biphosphate. Again, the phosphoric group is attached at carbon 1 of the fructose 1,6 biphosphate. And in step 4, what happens in step 4 is actually the splitting of the fructose 1,6 biphosphate right down the middle into two sets of 3 carbon fragments as shown in the structure. So this 6 carbon fragment is broken or splitted into 2 sets of 3 carbon in step 4, and that gives you the 3 carbon straight chains, producing 3 carbon fragments each. So note that the breaking or the splitting of this fructose 1,6 biphosphate does not take place when it is in the ring form. Rather, it takes place in the extended or linear form. And the splitting in this step 4 creates 2 molecules as shown in this structure. 2 molecules, one is the glyceraldehyde 3-phosphate and the dihydroxyacetone phosphate. Now, in the glyceraldehyde 3-phosphate, in the right hand of the glyceraldehyde 3-phosphate is the, sorry about that, right, so in the right hand of this glyceraldehyde 3-phosphate is the aldehyde group, is the aldehyde functional group. So this is it. Let me just get it here. This is the aldehyde functional group, and in the left hand side is the phosphate group, as you can see. So this breakage is actually seen from the breaking of the splitting of the fructose 1,6 bisphosphate as shown here. Okay, so we have the first 3 carbons showing glyceraldehyde 3-phosphate, and we have the second product of the splitting, which is the dihydroxyacetone phosphate right here. The dihydroxyacetone phosphate. This is the structure right here. So this is the dihydroxyacetone phosphate, which is the second product of the splitting, and this ends up being converted to glyceraldehyde 3-phosphate in step 5. So what happens in step 4 actually produces 1 molecule of glyceraldehyde 3-phosphate and dihydroxyacetone phosphate. This dihydroxyacetone phosphate ends up being converted to another molecule of glyceraldehyde 3-phosphate. So this shows the preparatory phase of the glycolytic pathway in 5 steps. So we begin in the next steps to look at the payoff phase of the glycolytic pathway, where the rest of the structures will be looked at from step 6 to step 10.